Okay, look at the number 4 first. A man 2 meters tall walks at the rate of 2 meters per second towards to a straight light that's 5 meters above the ground. At what rate is the tip of his shadow moving, right? And just be careful here. When you have this kind of questions, you can like directly do it, but since this APAC, they try to put the question in each small steps, so we follow them here first, okay? So you can generally draw like this, like you have, this is the ground, okay? This is the ground. And then there is a street light here, okay? This is straight light, huh? This straight light like this. Straight light, okay? Straight like that. And then there is a person which is what? Who is 2 meters tall. So the person may be like this, okay? This person, 2 meters tall. And then moving towards this direction, right? Of course, because of the lights here, they will have what? The shadow on this one. See that? There's a shadow here. This is where the tip of the shadow of the person from the lights. Now, the question asks you how fast the tip of the shadow moving go this direction. What's the speed of that? Okay? So let's look at the first question. What rate is given in this problem? The given is what? For example, I assume this part to here is considered the x, okay? And the tip of the shadow between the distance with the street light is y, okay? So when you have that, we can answer this question now. What rate is given to this problem? The rate give you what? This person move at what? 2 meters per second towards the street light. So that means this is 2 meters per hour, per second, my bad here. So this one should be, let me erase this part first, okay? This one should be 2 meters per second, go this way. So from here we can see that dx dt will be what? -2 meters per second. The reason for that is because we put the convention, this direction x is positive, and then go up will be the positive like that, okay? Here nothing with the going up, but just horizontal motion. So we don't need this part. We just need the direction of the motion to the right will be positive. So this one, oh, wait a minute. So this, no, it's not like this here. The distance, the dx dt must be negative. You know why? Because we're using what? The distance x between the street and the person, right? Because this distance is getting smaller and smaller. It's not like right is positive, not that case, okay? So this one moving to this direction, because x represents the distance, x represents the distance in between the lights and the person. This one is what? Getting smaller and smaller. So that's why dx dt is negative, 2 meters per second. The what rate given in this problem, the rate given is this, dx dt equals -2 meters per second, okay? Your answer must be including description of the world's rate of change of what? Rate of the change of the distance, right? This here must be what? The distance between the person and the distance between the person and the street light with respect to the time, okay? The number and the units, mathematical symbols, the rate, definitions of letters you have chosen for the variable. So now you gotta go this way here. When the person moving to the right, and then the tip of the shadow, the distance y to the street. So actually they ask you for what? dy dt, right? Because that's what I'm looking for. Huh? That means what? At what rate the shadow going, right? Okay, they said what rate asks? They ask for dy dt, right? And the answer was including the screen of the word rate of change of the distance of the tip of shadow to the street light. And then this side should be with respect to what? The time. Okay? So this is the overall the hint about this question. They give you the hint and that guide you. Okay, so here we know this is regarding what dy dt means what. That's what it asks for the rate. Okay, so how do you do this one? Generally, like this kind of question, we need to use geometry to build up. We code it as objective function. Okay, objective function. Always for the derivative, like this kind of question. Objective function is this. We're looking for the dy dt. So we can find out, represent this distance from here to here as y minus x. See that? This is the from here to here. That's a y minus x, okay? So now we're gonna use the formula is this. Let me get different color here, okay? Yeah, this one here. This triangle, you notice that there is this triangle here, right? This triangle, and the other triangle is this, the big one here, this one, right? So you can see this small triangle and the big triangle, they're similar, right? Why similar? Both 90 degrees. And this angle is common angle for small triangle and big triangle. By AA postulate, we know this triangle and the big triangle, they're similar, all right? So when they're similar, we can do something now. We can do what? If two triangles similar in geometry, we know that the ratio of corresponding sides is equal, okay? The ratio, this side is small from a small triangle. This side is corresponding size from the big triangle, make the ratio of that. This one is 2. We know the person's height is 2. And then the street light height is what? 5, right? So we can make the ratio 2/5. And then same as what? This one, this is size from small triangle. So we have y minus x over the total, which is y. Do you see that? See, we do the ratio because two triangles similar, the size of proportion means ratio of corresponding sides 2 and 5. Same as the ratio of what? The y minus x from here to here to the total, which is y. Okay? So when we have this, we can do cross multiply. We go cross multiply, okay? We have what? 2y equals to 5 times y minus 5 times x, right? We do cross multiply. And then we try to simplify. We minus 5 at y both sides. We will get negative 3y equals to negative 5y. And then we can find y equals 5/3x. Get that? Now, since for this question, we're looking for dy dx, right? We're looking for dy dx now. So what we're gonna do is we simply do what? Derivative now. We do dy dx equals what? Equals to 5/3 times by dx, dy dt, about here. So we're doing dy dt. Why do dy dt? Because dy dt means what? The distance between the tip of the shadow to the street light, the y change with the time. That's how fast. That's the rate of the distance change, right? So this one dt dx dx dt means what? This person moving towards to the rate of this person moving towards street light. So you have 5/3, and then time by dx dt. We find it from here. That's a -2. So it's -2. So we got a what? Answer should be -10/3 meters per second. Okay, kind of a little bit crowded, eh? So we can find out the answer is dt. I put it here, okay? dy dt will be equals what? -10/3 meters per second. This negative shows that what? Every second, the distance between the tip of the shadow to the street light is smaller by what? 10/3, about like 3.3 meters per second, okay? So this is the way we do the number 4. And then we move on to number 3 now, okay? So number 3, oh, I have to erase this part first, okay? So we got like space there. Let's erase this part first. We go to number 5 now. For this question, number 5, here. When you look at number 5, they said what? 2 cars are both 0.2 miles away from the intersection. Car A is traveling at 40 miles per hour due east towards to the what? The intersection. And the car B is what? Traveling at 30 miles per hour due north away from the intersection. At that moment, are the car getting further towards or closer to each other? Okay, same style, this book question. They said what? What rates are given in the problem, right? So how do you find the what rate problem? It's better ways what? You sketch what they gave us. So that will be help us to what? To help us to visualize what's this question about, okay? So I put it here. We go like this. This is the intersection, right? And then we know this is the east, this is the west, this is the north, this is south, okay? So right now they said what? The car A is what? Traveling this many miles per hour east, due east towards the car. So it means the car is here. This is the car A here, okay? And this is what? Here, from here, this is what? 0.2 miles, right? Miles, like this. And then the other car is somewhere here. That's the car B, okay? The car B, oh, the car B is also 0.2. So this is a 0.2 miles. And then the car B is moving this way. Car A is moving this way. right? Now, if you have this situation, you can think about, I try to draw another one for you here so you can see clearly. It's like this, one car is here, this is like the A, this is like the B here. And then they ask what's the rate of change of distance, means is that closer or further apart, right? So we use this one is the A, this distance is the A, this is the B. So at this one they say here, what rates are given? Given is what? A is the distance from here to here, so you get what? dA dt equals what? Since we think of the go to right as positive, so this car is going to this way, so that's why dA dt is what? 40 miles per hour due east towards to this one. So that means this car moving to the left. So that means what? This is a negative 40, okay, miles per hour. That's this dA dt. And the other one is what? Going up here, right? So we knew what? dB dt will be equals to what? Positive 30 miles per hour, because you're going up as positive, okay? So there's a what rates are given, those rates are given. For each of the rates, your answer must be including description of the words, rate of change of what with respect of what. Of course, with respect of the time, right? Because this is about the speed. And the what change, that's distance, both A and B, distance what? Distance to what? To the intersection. Okay? So that's about. The number of the, and the units here is in miles per hour, right? Mathematical symbols and define the letter for each of them. So we said A represents distance from the car A away from origin, the intersection, and the car B represents distance away from between the car B and the intersection, right? Now, this one this A and B, they gave you just what? Just help you, guide you to go step by step to get this question down, okay? Now let's look at the B. What rate is asking for? They're asking for this distance is C, okay? They're asking dC dt. Means actually the distance between the two cars is increasing or decreasing like that, okay? Now, your answer must be including description of the rate of change. That means what? Change of the distance C. Change of the C, okay? Change of the C. C means what? The distance between car A and car B. And to the what? The time, okay? Now this is just a strategy and steps. And now we're going to do the math work now, okay? When we do the math work, the first thing first is, as what I mentioned from the question 4, we need to have what? Objective function, always, okay? Objective function is what? Because this is a right triangle, you see that? So you have what? C squared equals to A squared plus B squared, right? You know that, right? This is called what? Pythagorean theorem. So now we need to do is what? I'm going to show you how to apply the chain rule to the derivative. And that will be more convenient than solving. Of course, you can do this way. You can do C equals what? Square root A squared plus B squared, and then do the derivative of that, right? That's called chain rule. But here I can use another way. We can use what? Of course, we're going to use this one is called implicit differentiation, okay? Let me show you how. Keep in mind that the C, the A, the B, they are the function of the time, along the time passing, the function will be what? Change the CAB will be changing, right? So we can do derivative of this. Keep in mind we do d to the t, okay? We do d whatever to the t, like that, okay? So this one will be what? 2c dc dt. And now this one will be what? 2a dA dt. And plus this one will be 2b dB dt. See that? Of course, the 2 and the 2 can cancel. And then I would, because we're looking for this right now, right? So we can find what? D, C, D, T, okay? Equals what? Equals to 2 cancels already. So that's 1 over C. And time by A dA dt plus B dB dt, like this, right? Now, we know C right now here because they said that they ask you find what? At that moment, the car getting further apart or close to each other. At that moment means what? T equals, means A equals what? 0.2. B also equals 0.2. Because they told you that the both cars are 0.2 miles away from intersection. Okay? So from here, you can find the C first at the beginning, at the moment, both cars 0.2 miles away. So you can do that. This one here, you can get like square root 0.2 squared plus 0.2 squared, okay? You can find the C first. Okay, let's use the calculator to find the C first, okay? So you go square root parenthesis 0.2 squared plus 0.2 squared closing equals what? 0.2828. And then I use the fraction. Can we change the fraction now? No, still cannot. So this is about, okay, I just round it off, okay? 0.28 miles at the beginning. That's at the beginning at this one, this is distance, like that, okay? And this is 0.2. This is 0.2, you know that, right? So after that, we know the C already. And we can plug in everyone in. Because we know dA dt equals this. We know dB dt equals this. And also we know the C equals this. See that? And we know A is 0.2, B is 0.2. We just simply plug in every single information data in, okay? So I'm going to do is put it in like that. I put it here, okay? Now, we got what? 1 over C is 1 over 0.28, right? And time by A is 0.2. And then time by dA dt is -40, okay? And the plus the B. B is what? 0.2 also. And then time by dB dt. dB dt equals 30 miles per hour, like this. Got that, right? Now, after that, we can do something here now, okay? Let me just erase it. Give more space to us. Now here, we just simply do this now, okay? We do the calculation. We do 1 over 0.8, 1 over 0.8, this part, we do this part, okay? And that will be equals 3.5 some. And we time by parenthesis, and the 0.2 times by 40, which is -40, be careful. That's -40, and then plus 0.2 times by 30, like this. right? And then equals to, we find out this one equals what? About negative 7.07 miles per hour. This negative shows that the distance of the two cars getting what? Closer and closer, only at that moment, okay? Only at this moment when the distance away from intersection 0.2 miles. So that's the answer here, right? And let's recall what we have on this one, okay? They gave you one car is here. Is here one car at the beginning. They have one car is what here, right? And the other car is here. Both of them 0.2 miles away from the intersection. This car A go this way, and this one go up like this. Now they ask you the distance, rate of change of distance at this moment. That means 0.2 miles away from the intersection, okay? Now, what we did was we built up what? Objective function first. That's the key part. We use geometry, Pythagorean theorem, we got this first, right? After we got this, we can do the implicit differentiation. So you can find this. Keep in mind the CAB are the function of the t. So when you do derivative, you have to what? Do the power rule of that, okay, and the chain rule also. And after you solve this one, you got this. And then just plug in C, you can use the Pythagorean theorem, find C is here. And also, when you do the derivatives, the A and the B, be careful here, A and the B, they are what, 0.2 miles away. We knew from here, right? We knew from here. And also the rate, because the A moving to the left to the intersection. So that's why it's a negative 40 miles per hour. And the B going up is positive 30 miles per hour. We just simply plug in all those numbers and then we can get this answer. Okay? So if you have any questions, please let me know. Thank you. Bye-bye.